To continue from where we left off last week, the examiner starts off the question as this. They tell you tan theta is 3/4, well, 3/4. And then they tell you that theta is between 180 and 270. Now, if you look at last week's question, this part was a little different. Last week, I had theta was between 0 and 90. I changed it back to 180 and 270. Who could tell me which quadrant we are talking about? Quadrant 1, 2, 3, or 4. If I tell you theta is between 180 and 270, which quadrant is that? Right? That's the first thing you have to identify in the question. In case you all don't remember, right? Theta, the over here is 0 degrees, and you always spin anti-clockwise. So here's 0, here's 90, and you keep going. Here's 180, here's 270, and then eventually if you keep spinning anti-clockwise and you make 360, you go back to your starting position. So if I tell you theta is between 180 and 270, 180 to 270 is this region. Isn't that region 3? And that makes sense, right? Let me explain why that makes sense. Remember, tan theta, tan is positive in two regions. Tan could either be positive in the first quadrant or the third quadrant. We know this from all the weeks before. And so that means if I come and tell you tan theta is positive 3/4, like this value is a positive value, then it could either be in quadrant 1 or quadrant 3. The examiner, because there are two possible places tan could be positive, the examiner has to identify which region he is talking about because it will affect the calculations, okay? So, but he won't say quadrant 3, he will say it like this, between 180 and 270. Now, what we need to know, right? Some lines will be positive on this diagram and some lines will be negative. It's either going to be a vertical line or a horizontal line. Anytime a line is vertical and it's above the x-axis, doesn't that line up with the positive part of the y-axis? So if you see a vertical line and it's above the x-axis, the value on this line will be a positive value. If the vertical line is below the x-axis, then the value there has to be what? Negative. If you see a horizontal line in front of the y-axis, you notice that lines up with the positive part of the x-axis, that value will be positive. If you have a horizontal line and it's behind the y-axis, well, that value will be what? Negative. If you see a slanted line, all slanted lines have a positive value. Remember that, right? All positive values have all slanted lines have a positive value. And don't worry, I'm going to be saying this over and over in class today. You don't have to take that down. So last week I showed you a butterfly, right? A kind of butterfly diagram. So since we're dealing with the third quadrant, I want everyone to draw this diagram, and I want you to draw a right angle triangle in the third quadrant. The right angle triangle always touches the x-axis. Everyone do that for me. Once you identify the quadrant, draw a right angle triangle, and the triangle will always be starting at the origin, and it will always be touching the x-axis. Everyone draw that diagram for me. And theta is always the angle between the slanted line and the x-axis. So putting theta. The examiner told us tan theta is 3/4 or 3/4. So we go back to our three formulas. You all remember that tan theta is what? Opposite over adjacent. Look at there. Opposite over adjacent. So that means the examiner is trying to tell you in SMART that 3 is the opposite side and 4 4 is the adjacent because tan is opposite over adjacent. So if you are standing over here, right? The opposite side is what? 3. And the adjacent side would be what? 4. Everyone okay with that? Opposite over adjacent. Everyone putting that for me. You all realize the hypotenuse is missing, right? The hypotenuse is missing. Now we have to make some adjustments here, right? We have to make some adjustments. This 4, I know they give us positive 3 and positive 4, but once we put it on the diagram, we have to make adjustments. We have to ask, should the value on our diagram remain positive, or should we turn it to a negative? This red line here, the positive 4, should we change it to a negative? Yes or no? Should we change this to a negative? The answer is yes. Isn't this horizontal line behind the y-axis? Remember we said if you have a horizontal line, right? And it's behind the, just like a graph, right? Isn't this red line clearly resting on the negative portion of the x-axis? We need to change him to a minus. And this 3, should we change him to a negative? What do you all think? Should we change that to a negative? The answer is yes. Because it what? Doesn't this blue line line up with the negative portion of the y-axis? It's below the y-axis. So everything needs to change to a negative. It just so happens that both of them need to change to what? A negative. Could you all calculate the length of the green line using Pythagoras theorem? Remember, when you square any Pythagoras theorem, right? Remember, we're trying to find the length of the hypotenuse, right? Pythagoras theorem says you have to square something. Remember, when you square anything in the world, you just get a positive value. I don't care if your calculator shows you a negative value. When you square anything in the world, you get a positive value. And remember, all slanted lines have a positive value anyway. So could you all calculate the length of the green line for me? The hypotenuse. 5, right? Remember, if you have, normally 2 sides are minus 3 and minus 4, and we're trying to find the hypotenuse. So it's really minus 3 squared plus minus 4 squared, and your square root after. Minus 3 squared is positive 9, minus 4 is positive 16, right? Now, when you square anything in the world, you're going to get a positive value. So 9 plus 16 is what? 25. The square root of 25 is 5. Right. So now that we have all 3 sides of the right angle triangle, we can finish the question. The examiner asks us to find what? Sine theta. We go back to our form 3 formulas. Sine theta is what? Opposite over hypotenuse. If you're standing by theta, the opposite is minus 3 and the hypotenuse is 5. Opposite over hypotenuse is minus 3 over 5. You're finished with that question. If they ask you to find cos theta, go to the formula for cos theta now. Cos theta is adjacent divided by hypotenuse. The adjacent side is minus 4 and the hypotenuse is 5. You're finished. That's the end of this entire question. So in these types of questions, you have to identify the correct location of the right angle triangle. Ask yourselves, do you need to change the values to negative or does it remain positive? And then you always find the missing side of the right angle triangle. And then you use your form 3 formulas. Right? It takes a little bit of practice. This is only your first example. Don't worry, you're going to have plenty more. All right, so take down this question here, right? The examiner told you sine theta is minus 2/5. You notice that which region are they talking about? Which quadrant? First, second, third, or fourth? Which quadrant are they talking about? Right, Kemi, correct. Jared and Xylon, correct. John, no, John, no. Look, it's supposed to be the third quadrant, and it actually makes sense in two ways, right? Remember, the first way of figuring out is actually the third quadrant is because they told you theta. They actually physically wrote where theta is. Isn't it between 180 and 270? And we identified here as 180 if we spin it anti-clockwise. And over here is 270. So it is the third quadrant. Also, it kind of makes sense because sine theta is negative. Notice they give you minus 2/5. Isn't sine negative in two regions? Sine is negative in the third region and it's negative in the fourth region. So it could have never be the second or first region they were talking about. If they come and tell you sine theta is minus 2/5, right? And you know sine could only be minus, well, negative in two regions, the third or the fourth. Then you have to, well, then you have two choices. Then you read the question more to make sure which region they're talking about. And they clearly said it's the 180 to 270 region. So it's not the fourth region, it's the third region. Okay, cool, right. So a lot of people, they understood their mistake there. All right, so once again, we're gonna draw what? A right angle triangle in the third region. We don't already have a choice because that's the region they're talking about. And write your theta here. Everyone draw this diagram and draw the right angle triangle inside of it. 5. It have a minus sign. Now, when something has a minus sign, the minus sign can belong on top or the minus sign can belong underneath, right? I know when I was teaching maths and I told you that there's a minus sign smack in the middle. To make calculations easier, you always pretend it's on top. But the truth is, right, whether you pretend the minus sign has to go somewhere, it either goes on top or it goes underneath. The truth is, it don't matter where you put it. If you put it on top, or if you put it underneath in algebra, you're going to get the same answer. It's just that more people are accustomed seeing a minus sign on top now. So they just put it on top to make it mentally easier for them. But in this question, in these types of questions, we're going to have to reason out if that minus sign belongs to the 2 or it belongs to the 5. And it's going to be very, very easy. Don't worry. So it's a sine theta question. So sine theta is what? Opposite over hypotenuse. This is our form 3 formula. So the 2 is the opposite and the 5 is what? The hypotenuse. We'll figure out where that minus sign goes just now. So you have theta here. Theta is what? Opposite. Sine theta is opposite over hypotenuse. The opposite side is 2 and the hypotenuse is 5. Remember, the slanted line is always positive. So we're real sure that this 5 have to be positive. This 2, should it be negative? Yes. Isn't this vertical line below the x-axis? So that 2 should be negative anyway. Okay? So we figured out where the minus sign was going, right? Could you all find the missing side for me? Look at this side here. Isn't this side missing here? Find the missing side of the right angle triangle using what? Pythagoras theorem. You'll be using this formula because we're trying to find a regular boring side. Remember, when you square anything in the world, you get a positive value. Right? And you remember, you have to pretend you don't have a calculator. So no one's supposed to be sending decimals. Huh? If you cannot square root something, you have to reduce it using your surds knowledge. Remember, the hypotenuse is 5, and the formula says you have to put a minus. I'm doing it working up here, right? So the hypotenuse is 5, so it's 5 squared minus 2 squared, and we have to square root that. 5 squared is 25. The formula says you must put a minus sign. and minus 2 squared is positive 4. So you end up with 25 minus 4. Isn't that 21? Now, you cannot square root 21 in your head, right? And there's really no way to simplify the square root of 21, right? So you have to leave it as what? The square root of 21. How much people had the 21 but just didn't know what to do because you're so accustomed using a calculator? You didn't know that you have to leave it at the square root of 21, right? Right. So remember, you don't have a calculator, right? So you have to leave it in a surd form. So let's finish out the question now. We have all three sides of the triangle. The examiner asks us to find tan theta. Tan theta is what? We made a small mistake. Right. This square root of 21, do I need to change it to a negative? After we do the calculations, we're supposed to always ask ourselves, should we add a minus sign there? Yes or no? And by the way, this guy, I get the same questions over and over, right? Remember, you don't have a calculator. So what do you think would happen if you put it in decimals? The examiner going to give it wrong or take away marks. The aim of this question is to do it without the aid of a calculator. So the minute you put decimals, in my exam, if I give you this question and you put everything in decimals, I give you 0, right? That is 0 in the question, right? Right. We need to put a minus sign here because isn't this rested on the negative portion of the x-axis? And I forgot that. After we find a side, we always supposed to ask ourselves, should we change it to a negative or should we leave it as a positive, right? Great. So tan theta is what? Opposite divided by adjacent. So let's do that and we're leaving it as is. Tan theta, what's the length of the opposite side? Minus 2. And what's the length of the adjacent side? Minus 21, the square root of minus 21. Now, obviously, if you divide two negatives, you will get what? A positive. You have to cancel out the negative signs, at least for the examiner. Before anyone asks, if you leave your answer like this, a minus and a minus underneath, if you leave it like that, you know what you're telling the examiner? That you don't know that when you divide two minus, you get a positive. How do you think the examiner is going to react to that? Not too well. I would minus a mark, definitely, just for leaving it, for not simplifying it. Okay? Great. And let's do the last question quickly. We want to find cos theta. Go to your Form 3 formula. Cos theta is adjacent divided by hypotenuse. The adjacent side is minus the square root of 21. And the hypotenuse is 5. Ta-da! We finished 2 questions there. Right? I want to change up this question for you guys, and I want to see if you all will get. Actually, we'll just go to the next page. All right. So try this one, right? Let's give it a here what I want to change the Oh no, I did change the quadrant. In this question, which quadrant are they talking about? First, second, third, or fourth? Which quadrant are they talking about? Kemi, correct. John, correct. Danny, correct. Silent, correct. It's the fourth quadrant. Look at it. Between 270 and 360. Isn't here 270 and isn't here 360 if we spin it anti-clockwise? So get started in the question and draw a right angle triangle in the fourth quadrant. Remember, the right angle triangle will always touch the x-axis, and theta is always the angle between the x-axis and the slanted hypotenuse. Remember, you don't have a calculator. By the way, if I take the square root of 3 and square it, when you square a square root, the square and the square root cancel out. So if I take the square root of 3 and square it, you get 3. If I have the square root of 5 and I square it, I get 5. The square and the square root annihilate each other. They cancel out each other. That should help you a little bit. Right? Good luck. Take a 5 minutes. You don't have to get it correct. You just have to try. All right. So cosine theta, we're going to go to your form 3 formula, right, is adjacent over hypotenuse. So the square root of 3, I'll put a for adjacent, and the 5 is the hypotenuse, right? So the adjacent side is the square root of 3, and you notice it on the positive part of the x-axis, so he's supposed to remain positive, and the hypotenuse is 5, but the hypotenuse is always positive anyway. So I think all the values remain what? Positive. We have to find this missing side here. Now, for those who are a little bit lost, right? Well, now on the right track, I should say. Use this formula here to find the missing side, right? And then ask yourself after, when you do your calculations here, should this be a positive value or should this be a negative value? That is what you need to ask yourself, right? So some people, well, I don't want to call out the answers, and I don't actually know the answer as yet. I'm going to do the calculations up here, all right? So it have the hypotenuse is 5, so it's 5 squared. We're finding a regular boring side, so we have to use minus. And then inside here, we have the square root of 3 squared, and then we have to square root that. Now, 5 squared is 25 minus, now I told you, squared and square root will cancel out to give you 3. 25 minus 3 is 22, and we leave it as the square root of 22. We cannot simplify that. Right, so for those who were unsure, how much of you all got the square root of 22? Right, I know a few people did, but I know some people didn't message me to tell me, right? Tan theta is what? We have all three. Oh, no, I made a mistake. Should I put a minus sign in front there? In front of that 22, we have a vertical line and it's below the x-axis. Yes, we need to put it's minus square root of 22 because it's a vertical line below the x-axis. It matches up with the negative portion of the y-axis. Okay? Right. So tan theta, using our form 3 formulas now, tan theta is opposite divided by adjacent. The opposite side is the square root of 22, and the adjacent side is the square root of 3. All right? Yeah, you could leave it like that and it'll be okay in the exam, right? Where's the other one? Sine theta. Sine theta is opposite over hypotenuse. The opposite side is minus the square root of 22, and the hypotenuse is 5. How much of you all had those two answers before I worked it out? Right, try this one here. Let's see if you all get this one correct, right? I'll give you a full 10 minutes. I'm not rushing you. Good luck. You have to identify the quadrant and everything. So, they're talking about the 90 to 180 region. So I think that is region 2, quadrant 2. So I'm going to start you up here in case you didn't know where to start. That's your right angle triangle because 90 to 180, right? 90 to 180. And this is theta. Great. So remember, cosine is what? Adjacent. I'll put A for adjacent, and this is for hypotenuse, right? Adjacent over hypotenuse. So the adjacent side will be the square root of 5. Not written too good there. Right. And the hypotenuse part is 4. Now, I'm not putting whether it's positive or negative. You all need to figure out whether you need to add in a negative sign or a positive sign, right? That is as much help as I've given you up to this point. I'll jump in 2 minutes again. Now, this square root of 5 have to be minus. Look at it. It's clearly resting on the negative portion of the x-axis. The vertical line here is going to be positive because he matches up with the vertical part of the y-axis, okay? So, but anyway, let's do our calculations. This part here is missing, right? I'll do the, so we're going to use this Pythagoras theorem here. So, hypotenuse squared. Now, when you it's minus the square root of 5. Well, when you're using, to be honest, right? When you're using Pythagoras theorem, right, you don't have to pay attention to the minus signs, right? Because when you square something, it's going to end up being what? Positive in any case, right? So you have the square root of 5 squared minus what? No, sorry. It's the hypotenuse. My mistake, my mistake. It's the hypotenuse squared. So it's 4 squared minus the square root of 5 squared, right? I'm not even going to bother to put the minus sign here because when you square anything in the world, it's going to end up being what? Positive in any case. So it's 16 minus the squared and the square root will cancel out to give you 5. 16 minus 5 is how much? 11. Anybody have the square root of 11 here? Because we can't square root 11. So we leave it as the square root of 11, right? Because we don't have a calculator, right? So look for your mistakes there. Still giving you a minute now. Remember, this square root of 11 is going to be positive because it matches up with the positive part of the y-axis. See if you can send your final answers for part A and part B now. So let's finish out the question here. So it's tan theta is opposite over adjacent. Here's the angle, opposite over adjacent. So it's the square root of 11 divided by the minus 5 square root. That's part A. And for part B, sine is opposite over hypotenuse. Opposite over hypotenuse. The opposite side is what? Square root of 11 and the hypotenuse is 4. How much people had that waiting in their books to be corrected? Right. This is the same question. This one. It looks the same. This one. This one is minus 5. It looks the same, right? So let me change up this question for you guys. Actually, no, since it's the same question, right? Let's just move on to the sum and differences and other stuffies. All right. So I know some of you were waiting for this part of class, the sum and difference of formula. So take down this topic. Don't take down the other stuffies, right? That's just me being comical. Just take down sum and difference. And it's almost the same thing we just learned here, except it's going to be a little bit harder. Just a little bit harder. Recording. These are what you call your sum and difference formulas. Take them down. It's how much? 6 formulas, and I'm going to show you how to use them. All right, so let's see the first question. The examiner comes and tells you he has cosine A is equal to minus 2/7, right? And he telling you that the angle A is in which quadrant? Between 90 and 180 degrees, right? Which quadrant is that? That's the second quadrant because here's 90 and here's what? 180. So make sure you call the angle A because it's no longer theta. They gave the angle a specific name, A. What you need to do is find all the missing sides for A, right? And then you're going to do the same thing for B. But let's do it one at a time. Find all the missing sides for angle A. Good luck, right? Try to figure out if you need to change something to a negative or not. Now, cos theta is what? adjacent over hypotenuse, right? So we'll figure out where the minus signs going until after. So adjacent is here, that's the adjacent side of the triangle, and the hypotenuse is 7. Now the hypotenuse or slanted line is always positive. And this 2, this line here, definitely resting on what? The negative portion of the x-axis. Let's find this one here. Using this for, well, we all know Pythagoras theorem now. This is a regular boring side. So it should be 7 squared minus 2 squared. And we have to square root that. 7 squared is 49 and 2 squared is 4. How much people got the square root of 45? And it's going to be positive because this vertical line matches up with the red, with the positive version of the y-axis. Now, here's the thing. Did you all know this one could actually be simplified? The square root of 45 could actually be simplified. You know why? Let me explain. For those who know this is, right? 45 is the same thing as 9 multiplied by 5. So you can replace the 45 with 9 by 5. So that means the 9 gets its own square root and the 5 gets its own square root. You could square root 9 in your head, but you can't square root 5. Yeah, you have to simplify it if it's possible. So this square root of 45, unfortunately, to get full marks in the exam, you have to put what? 3 multiplied by the square root of 5. You have to do that. Otherwise, the examiner will take away your mark. All surds must be simplified. Now, you have to do the same thing for B. B is in which quadrant? The first quadrant between 0 and 90. So on the same diagram, if you wish, and the name of this angle is B, complete that particular right angle triangle. So B, if you're standing by B, the opposite side is 1 and the hypotenuse is 3. To find the, everything here is positive, right? Because this matches up with the positive part of the y-axis. The slanted line is always positive. And even when we find this line here, it will be positive because it resting directly on the positive portion of the x-axis. So we use Pythagoras theorem here. You'll get 3 squared minus 1 squared. Anybody got the square root of 8 here? But that one could be simplified. The square root of 8. Anybody got that? The square root of 8 there? 4 by 4. No. 8 is not 4 by 4. Right? The square root of 8. Remember, 8 is the same thing as 4 multiplied by 2. So each of them get their own square root sign. You could square root 4 to get 2, but you cannot square root 2. Right? So you have to replace this with 2 square root of 2. You have to do that in the exam. Right. So we all kind of almost finished with the question, right? The examiner wants you to find what now? That's only the beginning of the question. The examiner wants you to find what? The value of sine A minus B. Look the formula here. To find sine A minus B, you have to take the value of sine A multiplied by cosine B minus sine B multiplied by cosine A. Isn't that the formula? But that's the formula that's going to be on the formula sheet, right? Here's what you do now. You have to find the value of sine A, cos B, sine B, and cosine A, and substitute it in and try to simplify it as much as you can. Right? You're using these. I'll help you on the first one. How much is sine A? Do we have the value of sine A? Yeah. Sine is what? Opposite over hypotenuse. Because they're asking for sine A. So stand up by angle A. It's opposite divided by hypotenuse. So this part here is going to get replaced with opposite divided by hypotenuse. You have 4 more things to figure out here. And remember, you don't have a calculator. Well, you're pretending you don't have a calculator. Right? Opposite over hypotenuse is sine. Figure out, and remember, if it's angle B, they're talking about, you have to stand in the B triangle. If it's angle A, they're talking about, you have to stand in the A triangle and extract those particular values. Cosine B, standing by the B triangle. Cosine is adjacent divided by hypotenuse. Right. Sine B. Sine B is what? Opposite over hypotenuse, 1 over 3. And cosine A is what? Adjacent divided by hypotenuse. How much people have the correct values in the correct place? This is not a solving question. You just have to simplify the answer. How much people have those things in the correct place? Right. Now, there's nothing really much you could really do here to simplify. There isn't really too much. We could simplify this part to, let me get a different color. You multiply the top by the top. 3 by 2 is 6. And you leave it as the square root of 5 multiplied by the square root of 2. And the 7 by 3 is what? 21 minus 1 multiplied by minus 2 is minus 2. 3 by 7 is what? 21. Sorry, that's 27 right there. You can't really do much here, right? And 2 minus signs will combine here to give you what? A positive, right? You can leave the answer like this, or you could, since both of them have the same exact denominator, you can put it as this. I think the examiner would prefer this one here. But make sure you understand the simplification. Remember how you multiply fractions? You multiply the top by the top and the underneath by the underneath. But that's your final answer here. I think the examiner would prefer this one. This one looks, and if you look at the back of a textbook, you will probably see the one. If both of them have the same denominator, they put the denominator once. They find the LCM. Right? Another way, I guess someone, okay, there's another way you could simplify this. The square root of 5 multiplied by the square root of 2 will give you the square root of 10. Yeah, I guess this one looks a little bit better, right? Square root of 5 multiplied by the square root of 2 is 10 with a big square root sign over it. So yeah, that is also a simplification. And I think the examiner might prefer that. I didn't see that one. Right?